quiénes somos esta red llamada ReVolta, que no tiene que ver con la revolución, sino con una palabra gallega que significa volver a labrar, ReVolta, darle la vuelta a la tierra. Ese es el sentido del nombre de la red. Y por eso también tiene ese anagrama que tiene que ver con la tierra y no con la revolución. Aunque todo esto es muy revolucionario, por lo tanto, con dos nombres. Y ahora Eduardo Corbelles nos dará unos 10 minutos nos presenta quiénes somos, qué consiste la red, y ya seguimos normalmente.
Bueno, buenas tardes. Vamos a hacer una presentación muy cortita para aquellos que no sois miembros de la red, para que conozcáis qué grupo conforman, cuáles son los intereses que tenemos. Fijaos si va a ser corta la presentación, que por estas horas debería haber terminado ya. Entonces, bueno, muy rápidamente vamos a mencionar tres grandes cosas: una descripción muy genérica de quiénes somos, algo sobre las actividades que hemos hecho hasta ahora y algo sobre las herramientas de difusión con las que contamos. Bueno, ReVolta es una red formada con una financiación del gobierno autonómico, con una ayuda del programa autonómico para la consolidación de unidades de investigación. Es una red formada hacia finales de 2011, llevamos menos de un año funcionando y es francamente multidisciplinar, ¿no? Tenemos ahí grupos, puesto por aquí, economía ecológica, historia agraria, historia económica, ingeniería, relacionados con la relación del territorio, en fin, algo que a priori no parecería que pudiera cuadrar demasiado bien. Entrando un poco en detalles, pues son 5 grupos de investigación los que forman la red. El primero que voy a mencionar es este, Grupo de Historia Agraria y Política del Mundo Rural, acrónimo ISTAGRA, que es el grupo que actúa como coordinador de la red, es el grupo que inició el proceso de creación de la red, son famosos los fondos de crearlo, y que tiene, bueno, pues entre sus temas de interés, pues los 4 que hemos puesto aquí, relacionados con el cambio tecnológico en la agricultura, la historia ambiental, la historia forestal, aspectos relacionados con el mundo rural, aspectos de la guerra civil, el franquismo, la transición posterior, etc. A partir de ahí, un segundo grupo que forma la red es GESTI, que es un grupo también de la Universidad de Santiago, que tiene sus puntos de interés fundamentalmente pues, en la pesca, la construcción naval, la historia económica, la historia empresarial, arqueología industrial y cuestiones de comercio internacional. Un tercer grupo es el grupo de investigación en economía ecológica de la Universidad de Vigo, es el único grupo de los 5 que forman la red que no es la Universidad de Santiago y que trabaja sobre temas relacionados con agroecología, economía ecológica, energías renovables o iniciativas de consumo ecológico, cadenas cortas de consumo, etc. Y ahora vienen 2 grupos relacionados o que vienen del mundo de la ingeniería para contrastar con estos de las ciencias sociales. Uno de ellos es el grupo de construcción sostenible para el medio rural y natural que coordina nuestro compañero Juan Carlos Carrera, que acaba de llegar allí en la esquina, que trabajan sobre temas de alojamientos ganaderos, temas de evaluación de construcciones tradicionales, diseño de estructuras de madera, técnicas para evaluar propiedades mecánicas de la madera, es decir, aspectos más propiamente de ingeniería. Y finalmente un grupo al que yo pertenezco, que es el Laboratorio del Territorio, que también está radicado en Lugo, igual que el anterior, que digamos abarca temas un poco diferentes relacionados con la ordenación del territorio, con el desarrollo rural, temas de posesión y tenencia de la tierra, y después aspectos de sistemas de información geográfica, teledetección, tratamiento de imágenes y finalmente aspectos de cooperación para el desarrollo, ¿no? Algo también, ya solo por sí ya era bastante amplio. La red, en resumen, tiene pues, una serie de intereses comunes. Decía que a priori podría parecer que esos 5 grupos no tenían grandes puntos en común, a pesar de eso pues los tienen, fundamentalmente en el estudio de la funcionalidad y la conformación de los paisajes agrarios, el diseño, la forma, los efectos de las políticas agrarias, los principios de funcionamiento de la agricultura orgánica, aspectos de gobernanza del territorio, de ordenación, de planificación de usos, aspectos de la sostenibilidad de las actividades agropesqueras, que está relacionado siempre a alrededor del territorio y cómo los humanos utilizamos el territorio, cómo lo utilizamos históricamente. Ese es el punto de unión fundamental de la red. Hasta el momento hemos realizado algo menos de media docena de actividades. La primera de ellas fue en Arbo, en el Museo de la Lamprea, en septiembre pasado, que sirvió fundamentalmente para realizar una presentación de cuáles eran los grupos participantes, que nos conociéramos unos a otros, establecer una serie de debates iniciales. La segunda gran actividad de la red fue un seminario organizado en Ribadeo, en febrero de este mismo año, en la granja escuela Pedro Murias, un complejo ligado al desarrollo agrario de Galicia desde inicios del siglo XX, que contó con 30 participantes de fuera de la red, que era un evento montado fundamentalmente para personajes o personalidades del mundo académico en Galicia relacionados con la temática agraria, que fuera de relevancia, y se le planteaba a este conjunto de expertos pues, dos preguntas fundamentales, o una, ¿qué futuro para el mundo rural? Alrededor de dos ejes centrales, ¿no? De dónde venimos y a dónde vamos en cuanto a ese mundo rural. Y bueno, como no sería raro suponer, pues tampoco llegamos a una conclusión única, excepto quizá que aquello que conocíamos como rural agrario particularmente, ya no es eso, ya no es lo que conocíamos, pero la verdad es que no tenemos muy claro lo que es, ni qué podemos hacer con él, ni hacia dónde lo podemos dirigir, ¿no? Por lo tanto, podemos certificar una defunción del rural que hemos conocido hasta ahora. Sabemos que tenemos una incertidumbre, pero la verdad es que no sabemos desde qué perspectiva abordar el futuro, ¿no? Y el objetivo del seminario era fundamentalmente eso, ¿no? Certificar esa falta de seguridad que tenemos en esa persona. Y la última actividad realizada, escasamente hace 15 días, en la que participaron un gran número de los que estamos aquí, fue un seminario de campo, un seminario de trabajo en campo que titulamos Paisaje y Agricultura Orgánica en el Tiempo, que organizamos en la Serra do Caurel, una parte de las montañas orientales de Galicia, el límite con León, y que se planteaba pues, ayudarnos a conocer en campo cinco grandes aspectos, ¿no? Discutir en campo sobre el terreno, sobre 5 grandes aspectos que ponemos ahí, las condiciones en las que se realizaba la producción agraria, cómo podemos utilizar el paisaje como fuente de interpretación, cómo podemos leer en el paisaje algo sobre cómo se utilizaba, cómo se aprovechaba el espacio, cómo lo aprovechamos ahora, cuál era la lógica energética de toda la producción, todo el sistema de producción existente, o cuáles son las marcas que podemos leer en el terreno del abandono de sus sistemas, ¿no? Bueno, en el debate que tuvimos los 2 días que duró la salida, pues pudimos ver efectivamente que había, en aquella zona habíamos tenido en sus tiempos un sistema que estaba en equilibrio con el medio, que era capaz de mantener una población elevada, que contra lo que nos pudiera parecer hoy en día no había sido un área marginal, es decir, había sido un área productiva, un área capaz de sostener una densidad de población bastante elevada, pero que evidentemente el proceso de inserción en mercados más amplios, en cadenas de comercialización mayores, pues digamos que rompió ese equilibrio y dio como resultado el paisaje que podemos ver hoy, ¿no? ¿Y qué prevemos realizar? Pues fundamentalmente 2 grandes actividades hasta final de año. Una es una actividad que organizan los compañeros de Vigo, el 4º Congreso Internacional de Agroecología y Agricultura Ecológica, que tendrá lugar a finales de junio de este año. Y para cerrar la actividad de la red durante este año, pues un seminario sobre propiedad y tenencia de la tierra que en principio pretendemos celebrar en Lugo. No sabemos aún si alrededor de septiembre o octubre, ¿no? Coincidiendo precisamente con el 30 aniversario de la publicación del libro de Ramón Villares, La propiedad de la tierra en Galicia, que si no me equivoco hay una copia de la portada en aquel póster de fondo. Pues aprovechando ese 30 aniversario y aprovechando que cerramos las actividades este año, pues celebraríamos ese siglo. Canales de difusión que tenemos abiertos hasta ahora. Tenemos un canal de YouTube en el que vamos publicando algunos de los vídeos resultantes de las actividades, y gran parte del material se está difundiendo hasta el momento a través de la página web del grupo coordinador de Instagram, ¿no? Que pero en breve tendremos ya activa nuestra página web, que está en proceso de elaboración, a través de la cual podremos ir publicitando las actividades de la red y las actividades de los 5 grupos integrantes. Bueno, pues hasta aquí. Muchas gracias por la atención prestada y damos continuidad a la siguiente.
Muy bien, podemos seguir. Bueno, pues sin retrasarnos demasiado, casi continuamos con los puntos. El blanco izquierdo de ahora.
Advance the slides.
Now I think this is now should, yeah, it should use all set. Yeah. Yeah. As far as it works. Let's see.
Yes.
Yeah. Maybe it needs sometimes.
Well, it's so nice.
Yeah.
But I can just move the arrows if I need to. Sort of.
You regard?
I think I'll stay. Okay, well, yeah.
Bueno, todo esto lo hacéis el organigrama, cómo vamos a seguir la actividad y creo que el profesor Comfort no necesita demasiada presentación, aunque sí la merece, por supuesto, ¿no? Es autor de un trabajo pionero sobre el cambio en las grandes praderas. Trabajó en Texas, en la Universidad de Texas, y desde hace 7 años es profesor en esa trinchera. Y es, digamos, uno de los expertos que podemos encontrar en este momento en el mundo precisamente sobre el tema que aquí vamos a hablar. En estos 6 meses el profesor invitado está siendo disfrutado por nuestros colegas de Barcelona y gracias a ellos también está en este momento aquí, ¿no? Welcome.
Good. So, thank you for inviting me here. I'm very pleased to talk to you a little bit about the socio-ecological research of a research group that I've been part of for many years. And I want to thank you also for accommodating my English presentation. If you have trouble understanding me, please tell me and I'll try to explain more clearly. What I'm reporting on today is partly my own research and partly the result of a whole team of people that I've worked with at the University of Saskatchewan in Canada and the University of Michigan in the United States, going back to when I was in graduate school. And our project has been focused especially on the history of agricultural land use in the Great Plains of the United States and part of Canada. This is a very large grassland, a very relatively flat area. It makes up a big piece of the center of North America. So from Texas in the south, all the way up to the southern Canadian provinces in the north. And it goes from a very dry, short grass prairie, where the grasses are just a couple centimeters high in the west, to a wetter, mixed grass prairie in the center, and then a tall grass prairie on the eastern part of the region, where the grasses can be more than a meter tall. And then in this black area is where it begins to transition into forest, because higher rainfall allows trees to grow. This is a very large area. The grassland part is 160 million hectares, roughly the size of Spain, Portugal, France, Germany, and Hungary combined. Okay, so this is a very large region. And our project has been studying the agricultural colonization of this region since 1850. So when Euro-American settlers moved west of the Mississippi River and out into the plains in the late 19th century, they're bringing agriculture to this land for the first time. Native people had agriculture only in very small areas along the rivers. But for the conversion to agriculture, one nice thing about this region is that we have a good historical record from the very beginning. So from a socio-ecological point of view, we have documentary evidence about the land use and the environmental conditions and how they changed for land that is being brought into agricultural production for the first time. Part of the story, part of the history is this agricultural reorganization of land. And we've distinguished between different kinds of land use. Okay, so we have up to here 160 million hectares of the area, which in 1870 was almost entirely in pasture, that is in grassland, native grasses that were filled with cattle for grazing. And then as time goes by, this represents the plow up of land for arable agriculture. So the purple area up here is the plowed acreage. By the time we get to about 1930 or 1935, it reaches the peak. And the ever plowed, so we have never plowed pasture, 100 million hectares. Even today, most of the land is still in grass. The ever plowed, that's land that has been plowed for crops at least once in the past 150 years, about 60 million hectares. Within this, the great majority of that is rain-fed, what we call dry land crops. Okay, this relies on rainfall for the water. 39 million hectares. Only about 10% of cropland is irrigated today. About 6 million hectares irrigated. And this is the, this very small blue part at the top here is the irrigated land. So what you have is a process of plow out of part of the land. Only in the mid-20th century does some irrigation begin to start. And then also about the same time you start to have some abandonment of cropland. This is the orange part here. Land that was plowed and used for crops for a decade or 5 decades, but now is being taken out of production again. So we conceive of the land in these different categories over time. And what I'm interested in talking about today is really the history of the soils in this place. I titled my talk History from the Ground Up because I think that the story of soils is the crucial part of the economic history and the development and also the population changes that have happened here are all based on soils. And when I think about soil fertility, there are really 2 elements that are most important, which are nitrogen and carbon. The grassland ecosystem for 10,000 years before agriculture came was taking nutrients out of the air and putting them into the soil. The grasses take nitrogen out of the air, they take carbon, and when they die and decompose, some of that carbon and nitrogen remained in the soil. And over 10,000 years, it built up a very deep and very rich organic soil. When farmers came, then they began drawing on those nutrients for their crops. And so part of what our group has studied is the dynamic of these nitrogen and carbon flows through agricultural systems. Now, talking about the plow-up of rain-fed cropland, what we expected to see was that as soon as farmers started cultivating the soil, that the soil fertility would start going down. It turns out that that wasn't exactly right. In fact, for the first 5 years, soil fertility increased. Any idea why? Why would soil fertility increase when you start plowing grassland?
Because organic matter starts to decompose.
Yeah.
And yes, nitrogen and carbon living.
Yeah, that's exactly right. So you start with a grassland, when you plow it up, you kill those plants and they decompose and they put a little bit more nutrients into the soil at the beginning. And so what farmers saw was that their crop yields went up. They started high and they went even higher in the first few years. Then, after about 5 years, soil fertility began to go down quickly. And after about 20 years of continuous cropping, soil fertility continued to decline, but more slowly. But this decline continued for 70 years, up until the 1930s. Slow, steady declines in cropland, in soil fertility in cropland. Okay. Those of you at the back might have a hard time seeing this, but I'll just point out, I want you to look at the yellow line in the graph. This is the chart of soil carbon, starting in 1860 and going until 1955 on this graph. So you see soil carbon goes up a little bit at the beginning, and then it goes down quickly, and then down more slowly, and by the time we get to the early 20th century, carbon is less than half of what it was at the beginning. This is a story of soil mining, of taking nutrients out of the soil year after year and not replenishing them. Similar process for nitrogen, which you see the yellow line, nitrogen mineralization moving down with time. Okay, I'll move on. So, one thing that farmers experience, this chart shows corn yields, the yields of maize, of corn. Initially starting high, I'm sorry, this is in English measures, this is 35 bushels per acre. Then going down quickly for the first 20 years, and then down steadily up until the 1930s. And by the time you get to the 1930s, the yields are quite a bit lower than they were before. The blue line shows rainfall. This is a dry area. When it rains, the yields are higher. When it doesn't rain much, the yields are lower. So it's not only soil fertility, but also rainfall that we have to account for. But essentially, over the long term, the rainfall was fairly steady, and the crop yields were going down because of this soil mining process. By the time we get to the 1930s, the region had reached a crisis. And both carbon and nitrogen in the soils were only about half of what they had been before. This was a very rich region. It produced enormous amounts of grain, which were exported into the world market, all the way to Europe and to the industrializing cities in the eastern United States. But I think that this is something that could not have continued for more than a couple more decades before the soils were used up. Then what we see in the 1930s is a complete industrial reorganization of agriculture. You have a soil crisis that comes at the same time as a major drought. The 1930s Dust Bowl is about a 9-year period with below average rainfall. You have the external economic pressures of World War I, which drove grain prices higher, and then the Great Depression, which took grain prices lower, and then World War II, which raised prices. Farmers were responding to these ups and downs of commodity prices. And also a political change with Franklin Roosevelt's New Deal government becoming very active in trying to reform agriculture. So farmers are facing all of these pressures, both internal pressures in the soil, external pressures in the markets and in politics and in weather. And the result of this very difficult period in the early 20th century were 4 changes to the way agriculture operated. Each of them that broke through former limits on ecological and socio-ecological processes. The first major change is mechanization, a conversion from horsepower to mechanical power, to tractors. Here in the orange bars are the number of horses in the region. From 1870, going up steadily, peak at 1920, and then a very quick decline in horses. Farmers were trading their horses for tractors. The black line shows the dark orange bars show the number of tractors in the plains going up to a peak about 1954. So as farmers acquired tractors, they're doing away with their horses. This had implications for soils because horses were one of the major suppliers of manure that went back onto crop fields as a way of restoring soil nutrients. But this allowed farmers to break through the energy limits in terms of the amount of work that could be done by livestock, by animals. I think in the interest of time, we'll pass this one. No? 5 more minutes? Okay. So in changing from horses to tractors, one thing that changed was the crop selection. Farmers always had to grow feed to feed their horses. Once you didn't have horses anymore, then there was no need to grow so many feed crops. That allowed them to specialize in wheat, which is a cash crop. They lost manure, which I mentioned is important for soil fertilization. And they began using fossil fuels as their fuel. Up until now, the fuel for farm power was coming from corn. People grew corn to feed to their horses, which provided the power they needed. Now, the power is coming from outside the region in the form of fossil fuels for the machines. Second major change was the introduction of synthetic fertilizer. This allowed farmers to break through limits that had been imposed by soils. What it meant is that farmers could now begin to put nitrogen especially onto their crops each year as needed. This is the total amount of nitrogen fertilizer applied in the green line in the plains, going up and up and up and up and up. And over here we have the yields of the major crops, also going up and up and up. So as farmers began applying synthetic fertilizer, they were able to increase their production and also forget about soils to a great extent, because they can provide the nutrients the plants need on the spot every year. Again, this is a fossil fuel process because nitrogen fertilizer is mainly produced from natural gas. And a lot of the energy that farmers now put into their farms is coming in the form of nitrogen fertilizer. Maybe 60% of the energy inputs on a farm in the Great Plains are from the fertilizer that they put on the fields. So again, we're substituting fossil fuels in place of soil nutrients. Okay, now this is the same set of graphs I showed you, but now I've extended it beyond 1955 out to 2005 at the end. And one thing that you'll see is that the decline in carbon in this yellow line ends about 1955, and it actually starts going up a little bit, slowly, because nitrogen fertilizers allow a much richer plant growth. More carbon gets put back into the soil than had been the case before. So, although there are problems with using fossil fuels, there also are some benefits in terms of the soil conditions. See, here we have plant productivity. The yellow line is stable, 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 down a bit, and then with nitrogen fertilizers, plant productivity goes way up. Okay, so this is really a dramatic change in the farm system. We get nitrogen emissions as well. When you put nitrogen on the soil, part of it goes into the crop that you want, part of it goes into the atmosphere as a greenhouse gas. This is N2O emissions. This is a major greenhouse gas. After the addition of fertilizer, the nitrogen dioxide emissions go up and up and up. Okay. Third major change is irrigation. Here we're breaking the limits of rainfall, the limits of soil moisture. This entire area represents a very large underground aquifer, and with fossil fuel technology, with pumps powered by diesel fuel or by electricity, farmers could pull this water up and irrigate part of their land. It's about 10% of cropland, but it's probably about 40% of total production is coming from irrigated land. And you see this typical landscape pattern that results because the sprinklers are circular. And so what used to be nice square fields have now become circular fields for irrigation in the plains. But the water is very deep. The water is 400 meters below the surface. Before fossil fuel powered pumps, there was no way to get the water up to the surface. This is the reason that irrigation only began in the 1940s in the plains, is because you needed this external energy supply to lift heavy water up to the plains. Irrigated cropland, same chart here, but we're looking at the blue line now. Irrigated land also increases plant productivity. And so the carbon content of irrigated land started going up. The plant productivity went up rapidly with irrigation. Nitrogen mineralization went up. So bringing water to this relatively dry place really increased the productivity and also increased your nitrogen emissions. The N2O in the blue line is going up very steeply as well. Almost done. The fourth big change was what I call a land dividend, because increasing productivity in the late 20th century has essentially allowed farmers to set aside land that they no longer crop. About 25% of cropland has been retired from production since 1955. And this is because with industrialized agriculture, the most marginal land is no longer productive enough to be profitable. And so we have essentially an ecological recovery going on as a result of this change. So we're putting a lot of fossil fuels into the land, we're increasing productivity, we're changing soil dynamics, we're changing atmospheric emissions, and we're also changing land use on a significant range. This is a major land use and socio-ecological reorganization that has gone on. When nitrogen and carbon go out of soils, they eventually go into the atmosphere. So part of the story here is about greenhouse gases. And if you look at the total emissions of agriculture over time, everything above the line here is greenhouse gas emissions. And only in the 1960s does the line go below zero. That is when now agriculture is taking greenhouse gases and putting them back into the soils. So there's a sequestration process that's the result of this new industrialized agriculture. But if you take the entire 150 years, the total greenhouse gas emissions from this region are equivalent to 17 coal-fired power plants operating continuously for 150 years. Or the same as 2.25 million cars driving constantly for 150 years. So this is a significant greenhouse gas flux that is related to this agricultural colonization process. Okay. I think I'll stop there. And I don't know if you want to do questions or... No, thank you.
Bueno, tenemos ahora 10-15 minutos todavía para preguntas, sugerencias, iniciar el debate. Así funcionará el seminario. Como dije antes, pero bueno, creo que ya lo sabíais todo. Una intervención breve de 20 minutos y otros 20 minutos de 20-25 de discusión. ¿Quién abre el fuego?
I'm not sure if this actually is similar yet, but I've heard that you've been working on an article with Cashman,
Yes.
and it's about the end of the century crisis and the different fertility systems.
Yes.
I don't know if you could explain this a little further or tell me if this is similar already.
Yes. So this is a paper that Freeland Kraussman and I will be presenting in Columbia in 2 weeks. It's not quite finished yet. But what we've done in that paper is to look in more detail. Let me just show you a map here. Yeah. So this is the state of Kansas, right in the middle. And this paper that Friedland and I are working on, we take 6 communities across Kansas in the 3 different grassland zones. And we compare especially the colonization process using socio-ecological indicators. And what we're finding is quite interesting, that farmers initially begin with a soil mining process where they're growing a lot of cash crops and pulling nitrogen out of the soil quickly. But then after about 20 years, they start to diversify more. So crop diversity goes up, and nitrogen return to the soil goes up. Now, by European standards, they're still very low. Nitrogen return in Kansas was usually about 20%. That means of all the nitrogen they take out in a year, they put 20% back. And then the next year they plant again and do the same. So this is a real extraction process. But by the 1930s, in these communities, the nitrogen return has gone from 20% up to 50 or 60%. So it's still a soil mining process, but we also see an adaptation going on where farmers are trying to address their soil problems in different ways, leading up to the 1930s. So
there's no relation between these 5 first years where soil fertility goes up. But you mentioned before.
Yeah.
I'm sure that's connected with the. It also explains this end of the century crisis according to economic standards.
Okay.
But coming from fertilization key point in this connection.
Exactly. I think that, I mean, ultimately, even if you're putting 60% of your nitrogen back on, you're still going down every year. You're still drawing on stockpiles. You're just doing it more slowly. That first 5-year bump is fairly small when you're looking at 150 years of span. And so this little increase in soil fertility gets used up quickly. But the paper will be written soon, and I can send you more details.
Yeah, I was just
Yeah.
curious, because I read about it on that book that was published last year. But I
Yes.
wasn't sure if it couldn't find it or something.
Yeah, so we've published one article using just one location in Global Environment from 2 years ago. The paper we're working on now is much more detailed and uses more examples. So hopefully that will be ready soon.
Question about what you were saying in the end. This land that is removed out from this land that is removed out from the soil because of low productivity.
Yes.
What is
What happens to it?
Yeah.
Yeah.
What happens to it?
Yeah.
It's not for production anymore. It's for small production.
Mm-hmm.
I find it interesting and somehow a bit. The idea is also a bit dangerous because to say that
Mm-hmm.
thanks to industrialization, we are having a more sustainable
Well, yes,
system in the end because of removing this land.
yeah, so I would not make that argument. I think in the big picture, it's an
Okay.
environmental loss.
Yeah.
But I also think that we have to be nuanced about it to say that it's not entirely in one direction, that there are complicating factors when things change.
But in any case, it will depend also
On
what happens.
on how it's used, of
Yeah.
course. Okay, so what we call retired land, before 1987, about 10 million hectares were retired by farmers on their own, by their own decision. And most of that land was taken out of crops, returned to grass, and is now grazed by beef cattle. Okay, so they're taking, they're calculating that they can make more money raising cattle than they can planting crops. So it's not that it's not used, it's just that it's used differently. There's another category, another 5 million hectares after 1987 that come from a government program called the Conservation Reserve Program, CRP. Conservation Reserve Program requires farmers to take land out of production and they're not allowed to graze it. They have to replant native grasses and leave it be. And the government gives them annual payments. Okay, so this is meant to be both a conservation program for ecological benefits and also a farm support program to give subsidies to farmers. And so at least on this part, there are clear ecological benefits. What we've seen in the last 20 years or 25 years is an increase in plant biodiversity, increase in bird biodiversity, insects are doing better. So, and in fact, what we've shown with our studies is that soil nutrients are increasing in the soil in that land also. So for part of this, you can say that there are ecological benefits. Now, as I say, that doesn't mean that all of those fossil fuels that are being dumped in to the rest of the farm system are not causing other problems, and they certainly are.
What is the problem with erosion and irrigation now for the future? You're still using winds, for example, or irrigation?
For irrigation, wind,
No,
not for irrigation, no,
just electricity.
just electricity. Yeah, the wind-powered mills can raise water only a short distance. There's not enough power, and the water there is much deeper. Okay, so when farmers first moved out, they put up windmills, which was enough for subsistence. That gave them water for, well, 2 hectares of garden crops or to water 5 or 6 cows, but that was all that a windmill could produce. So it's only with fossil fuel powered pumps that they have water on an industrial scale for crop production. So windmills are gone.
So it's about the future, about Ogalala aquifer.
Yeah, yeah. Yeah, the Oglala aquifer is disappearing. And it's not coming back. Yeah, so this is another sustainability issue. Irrigation, this is a Pleistocene deposit of water that is never replenished. So as they use it up, it gets deeper and deeper. And you know, they've been irrigating from that source for 50 years now. They're becoming more efficient, but eventually they'll run out. And so this 10% of irrigated land will eventually change again.
For costing how many
How
years?
long?
How long it will take?
Yeah, the problem is that they've been forecasting this since the 1950s, and it keeps getting longer and longer. Yeah. Well, because at the beginning they were very wasteful with water, and half of the water they pumped up evaporated before it got to the crops. Now they're getting worried about running out, and they're becoming much more efficient. So now 80% of the water gets to the crops, which means that your timeline in the future gets longer. So I've been studying this for 20 years, and when I started, they said we only have 20 years left before we run out of water. But now they're still saying maybe 20 or 30 more years. So it always seems to be in the distance. But what we do know is that some of this is already changing. The acreage irrigated has started coming down since 1990. So that the most marginal irrigated land is shrinking in towards the middle. So it's, again, this is an unsustainable kind of a land use, but it's one that could be supported maybe for 50 or 60 or 80 years in total.
Tengo dos preguntas. Try to translate.
Thank you.
La primera es muy conocido el desarrollo de la ciencia de la conservación de los suelos en la década de 1930-1940. Mi pregunta es, ¿qué tan efectivas fueron las prácticas de la soil conservation para detener ese proceso de degradación de los suelos? Y lo segundo, si cuando se expande la mecanización a partir de 1940, esas prácticas se hacen a un lado o se mezclan con el nuevo modelo tecnológico.
So basically, the question is about the soil conservation system and the service, and those parts of the Department of Agriculture that were working for improving practices with for soil conservation and so on.
Yes.
And the question is, were they effective at all in the first period, in the 20s and the 30s? And there's a second question concerning after mechanization in the 40s and 50s. Did they took those services apart, or they continued working on them and being effective in that?
Okay, good. So the soil conservation efforts from the government really began in the 1930s for the first time. And they encouraged farmers to, they were mainly concerned about erosion, not so much about soil nutrients at that point. It was mostly about erosion because this was the time of the drought and the dust storms, and erosion was a very big concern. So they encouraged contour